Hello guys, so welcome to another session of AWS Cloud Database Administration. My name is Martin, as usual, and today we have a very interesting topic. We're going to be talking about best practices involved in deploying a production RDS instance. Okay, so we'll be looking at the recommendations by AWS as far as deploying a production RDS instance is concerned, right? It could be a Postgres RDS instance, any relational database instance that is being supported by Amazon Web Services. Okay, so let's move in. Yeah, guys. So, why is this session very important? Because this is very critical for production applications. Like if you have a production application that needs a production RDS instance, we recommend that you follow these best practices to make sure that your RDS instance is secured, can perform well, you have full control over it, and you can like there's high availability and there's also disaster recovery. Okay, so as far as these recommendations are concerned, we are going to be looking the various elements like isolations and control. We're going to look at elements like high availability and recommendations, disaster recovery recommendations. We're going to look at regional disaster recovery recommendations, security, and performance. All right, guys, these are just some of them, but these are the basics, right? Like the basics as far as deploying a production RDS instance is concerned. It's not all, just the basics, right? So I will identify each of them, then I give you the recommendation and why that is recommended. Okay. So for isolation and control, sorry, just missed this. For isolation and control, we recommend you go in for a custom VPC, like you have full control. You create a VPC that you have full control over it. Right? Like have your virtual network, right? Make sure that you are deploying your RDS instance in an isolated virtual network that you have control over it. You know that I have my RDS instance in a virtual network that maybe can give me maybe 65,000 IP addresses, so I can deploy 65,000 RDS instances. Okay. Then for security groups, maybe for naming conventions or for making sure that like your resources are follow the naming convention as per your run book, right? And also for parameter group, we say we recommend you go for custom parameter groups, right? Why do we recommend all of this to be custom as far as the networking or as far as the virtual network of your RDS instance is concerned? It is to avert downtime, okay, and to make sure that you have full control over it in a later date, maybe when you need modification. What do I mean by that, guys? It's very important for you to know that default parameters, default settings, default resources, when you use them in deploying your RDS instance or deploying your AWS resource, you do not have full control over that particular resource, right? Why? Because you have used a default, right? All right, or you have used it could be a parameter or a resource that you do not have full control over it. Okay, and let's say for the case of a parameter group, let's say you use a default parameter group to create your RDS instance. What happened? Maybe you want to do some changes in that parameter group. Maybe your RDS instance, the number of connections for your RDS instance have grown, your database has grown, and you need to do some changes. Maybe change some parameters. Maybe you want to change maximum number of connections. You want to change timeout. You want to change some stuff in your RDS instance. And if you were using a default parameter group, guys, that would be a serious blockage because you cannot modify parameters of a default parameter group. So, and for you to change that parameter group to a custom parameter group, you will must require downtime. Okay, there must be downtime because you will need to create a new parameter group. Now you use a point in time recovery or a snapshot to create another RDS instance. Just imagine if you have an RDS instance that is 1 TB, right? That is 1 TB, and you want to create another RDS instance just simply because you use a default parameter group to create your RDS instance. And at this juncture, it can take even an hour or two to do that. And this will be a very serious problem as far as downtime is concerned, because you will need to request for emergency maintenance window to do that. Okay, so that's why we say at the beginning, at the baseline, when your RDS instance is still growing at the beginning, just make sure that you have full control over these resources that you deploy by using a custom parameter group, custom VPC, custom security group, and so on and so forth. Okay, so in a moment where maybe you need to do some parameter changes in your RDS instance, you don't need to bother yourself changing the parameter group. You just go to the parameter, you check if it's a static parameter or a dynamic parameter, and you do the changes, right? So that is very important, guys. So the next element is high availability and disaster recovery. What is the recommendation? Recommending you should go for multi-AZ instance. What is a multi-AZ instance? When you deploy a multi-AZ instance, as I previously explained, you're going to have a primary instance in US in maybe in AZ1, and you're going to have a secondary in AZ2. What happens is that if AZ1 is down, AZ2 will obviously pick up and continue serving your application. Okay, you will continue serving your application without any problem. And this primary instance and this secondary instance, they are in synchronous mode. Okay, they are in synchronous mode. What does that mean? Therefore mean when you send a request, maybe a commit, or when you send a request into your primary instance, it is first of all written to the secondary and committed before it is now committed in the primary. Therefore mean that they're always synchronous, right? So you do not have any data loss. Is that okay? So that's why we recommend you go for multi-AZ RDS instance. Okay, and for regional disaster recovery, remember guys, normally RDS instances, like when you go for multi-AZ, you're going to have AZ1, AZ2, AZ3, AZ4 in a region. This region could be US East 1, right? Now if you configure multi-AZ with between US East 1A and US East 1B, what happens when US East 1A is down, right? Okay, what happened when US East 1A is down is that US East 1B is going to take off. Now, what happened when the whole region itself, that the US East 1 region is down? Right? If the whole region, US is one region is down, even if you configured multi-AZ, you will lose, you will not be able to have high availability and disaster recovery, right? So that's why, because the whole region is down, that's why we recommend that while you deploy your RDS instance, at least for regional disaster recovery, make sure you have a cross-region snapshot available, or you configure a cross-region replication, or you may even use a reader instance. What do I mean? For your multi-AZ instance, when you deploy a multi-AZ instance, maybe in let's say EU West 1, you can just simply create another reader instance that is in a different region far away, maybe in let's say Europe, or AP, let's say AP South 1. What does that mean? It therefore means that when normally your primary region is US is 1, and you deploy your resources in US is 1, and you're working properly, if the region US is 1 is down, that reader instance which you created in AP South, right, it will still be available because you were replicating data to that region. What will happen is that you cannot move directly to the AP South region and promote that your reader instance to become a primary, and you keep serving your application without any problem, and you can now maybe fix that, but while waiting for the region to be fixed. Is that okay? So for security, guys, we recommend you use the AWS Secret Manager to manage your secret. Why do we do that? Because sometimes secrets are being written on bare platform, on text form, maybe on piece of papers, maybe on OneNote, maybe like those are security vulnerabilities, right? Secret is not good for you to expose your secret on text on a text format, maybe on piece of papers, or maybe on OneNote, or so on and so forth, right? So when you deploy your secrets in AWS Secret Manager manages these secrets, and you just decrypt, and you just decrypt this secret with a encryption key, and you're able to use it. And the secret manager also helps you to do the rotation and so on, so you are very sure that your secret are secured, right? Then we also recommend you deploy your RDS instance in a private subnet. Very important. Private subnet, so much so that it is not your RDS instance is not exposed to the public, guys. Your RDS instance should never be exposed to the public as far as the production is concerned, right? Then we also do not recommend you should use master credentials in your regular day-to-day activity. Use master's credentials should be reserved for specific purposes, maybe for CTO, maybe for senior database administrator, for specific tasks, right? So you can always, if a DBA or if a user needs access to your RDS instance, create a user with a least privilege and grant him permission with least privilege for him to do whatever I want to do with that, right? So for performance, yeah, we also recommend that so many recommendations as far as performance is concerned. But for me, what I have noticed or what I deem very important for people to note is about scaling traffic. Performance traffic is very important. Scaling, how do you scale traffic? AWS gives you the opportunity to add a a read replica to your RDS instance, right? You can add as far as 15 read replicas to your RDS instance, right? Yeah, some 15, some less than 15. So what does that mean? If you have your normal RDS primary instance, that's a call it a writer, and you can add a read replica to it in such a way that you will now serve your application in two ways. Read traffic is being directed to the writer. Sorry, write traffic is being directed to the writer, and read traffic is directed to the reader, right? How do you know that you have a lot of traffic? You just need to use the CloudWatch metric and see calorimetry and see the traffic, right? See number of connections, see CPU utilization, see the buffer cache hit ratio. Look at those metrics and see that. And you can also use some activity monitor. Maybe in Postgres we talk of PG stats activities to check. Like look at what is going on. Look at the kind of queries that are coming in. If most of these queries are select queries, it therefore means that you have huge traffic. And if this traffic is skyrocketing and you cannot, there's no way you can kill a process or kill a session, it therefore means that you have huge traffic and you need to be able to scale. So what you do is that you say, okay, no problem. You send read traffic to a reader instance and you send write traffic to a writer instance. And this is going to boost your performance. Okay, guys? Yeah. So we are moving to our RDS management console to do this demo, right? So I'll be showing you how to do this deployment from your virtual networking right down to deploying your fully controlled, secured RDS instance. Okay, guys. So see you soon. Yeah. So before we move to the console, remember this is the kind of architecture that we're going to be deploying. First, we are going to choose our AWS region, right? Then we are going to deploy our virtual private cloud. This is our virtual network. That on not using the default, right? So we probably to have a virtual private cloud that it can give us a lot more number of IP addresses. We can go for maybe the 10 like 10.0.0 version with 16. This can give us maybe more than 65,000 IP addresses. Then we're going to have two private subnets, right? And we're going to have two public subnets, right? You see the way I arrange my subnets. Look at my first private subnet. It is 10.0.2 CIDR range 24. What happens is it shows me, like, it gives me total control and visibility for my area, for my resources, right? And public subnet 2, we have 10.0.1, right? CIDR range 24. And we have public subnet in AZ2, another public subnet in another public subnet in AZ1. So what does that mean? If you look at this critically, you see that if I see a resource that whose IP address is, let's say, IP address ranges from 10, let's say 10.0.4.2, maybe 4.5, I already know that this particular resource is a public facing resource because of the CIDR block range, right? The CIDR block range I've already I predetermined, right? And if I see an IP address maybe for my RDS instance that maybe is 10.0 dot maybe 1.13, I know that it is a private facing resource because I have full control over this virtual private network. I am the one who determine, I am the one who actually outline how I want this virtual private network to look like. The same thing with this. So it therefore means that when I see any resource that which CIDR range is 2. I know that it's a private for AZ1, and the one that is 1, I know that it's private for AZ2, and for 3 and 4, like 3 and 4, I already know directly that they are publicly facing resources. Okay, so that is how you deploy, like you deploy isolated resource, could be an RDS instance or any other resource, right? Now, for your RDS instance, we're going to go for multi-AZ. You see that you're going to have a primary RDS instance in AZ1 and a secondary in AZ2. It doesn't mean that we're going to deploy it. We're going to deploy just this one. Then we select multi-AZ. We are going to accept multi-AZ. When you accept multi-AZ, a secondary replica is created. A secondary replica doesn't mean that you will see it. You do not see it, but a secondary replica is created by Amazon Web RDS internally. And in case this region goes down, okay, this secondary replica will become the primary, and you'll be able to serve your traffic. That's the reason for multi-AZ. If you went only for single AZ, you only have this primary instance in your single in a AZ1, and in case of a disaster recovery, I mean, that is over and game over for you, right? Okay, guys, so let's go to our AWS management console and do the network configuration deployment right up to our RDS instance. Okay. Yeah, so normally for the deployment, we need to start with the networking part of it, right? So we need to start with the networking part of it. We need to deploy our VPC, we deploy our subnets, we deploy our route tables, deploy our internet gateways. Then we do a bit of routing. Remember, when you design your virtual private network, you need to do the routing. Routing is routing traffic from one particular resource to another, or one particular area or resource, or a VPC to another, right? So we need to do a bit of routing. Then we'll deploy our security group, deploy our subnet group, deploy our custom parameter group, as well as we do security group adjustments to allow firewalls, right? To allow firewalls, like allow traffic into our RDS instance for connectivity. Okay. Yeah, so we are now in our AWS management console, and we want to deploy a production RDS instance that is well secured, isolated, and we have total control over it, and we can scale at any moment. Okay, so we start with the networking, right? So we select VPC. You can search on VPC, but I already have it here, VPC. Okay. Yeah, so when you have the VPC, you can like create VPC. And here you have two options. If you want to just create a VPC only, I mean, this is not even necessary. You want to create a VPC only, you can go for VPC only. And you want to create a VPC and more, that's VPC and its related resources, like the route table, like the subnets, and so on. You go for VPC and more, right? So you need to name your VPC, okay? And you can, I always like auto generate, right? You check auto generate so that all resources will be named based on your VPC that you have named. So let's call this our RDS VPC. So let's call this RDS. Okay. So if I see, as you have selected RDS, it has named your VPC RDS VPC. Okay. And each resource as far that's connected to that VPC will be named with RDS, right? It starts with the prefix RDS. So you see RDS subnet public one, RDS, like it has given you all of these elements, right? So now let's go for our virtual private network side range. So CIDR range, yeah, we can go for 16.10.0. This is going to give us 65,000, more than 65,000 IP addresses. That's fine. So I go with that. Then now for availability zones, I took two availability zones, guys. You can go for three, right? You can go for three. You can go for as far as, yeah, you can go for three, no problem. Then you can go for cost. If you see the custom AZ, so you can I select EUS1A and EUS1B based on our design, remember. Then now number of public subnets, I go for two public subnets, and um, a number of private subnets, I go for two private subnets as per our design. So let's go for CIDR block range. This is important. This remember, the first one, public subnets. Our public subnets, we said should have CIDR range like three, like 324, right? 3 and 4 for CIDR range 24. So public subnet EUS1A. So I said here 3 CIDR range 24. Public subnet side range US with 1B. So I go with 4 and setup block 24. And private subnets we said should be 1 and 2, right? So I'll go with 1 setup range 24. And the other private subnet, I'll go with 2 and setup range 24. Okay, then you see, like, all resources have already been named, and like based on the prefix that we set RDS VPC, you see we have our subnets well identified, we have our route tables. Okay, but you can still create all of these one after the other, but for the sake of not wasting time, you can just do that immediately. You can see that all resources have been created already, and if you want to add tag, you can add and you create your VPC. Okay, so you can see that the VPC and resources have been created, and yeah, you can have, like, this is what you call, this is my RDS VPC. Okay, so you can now go to view VPC, and you see that your VPC has been created, and you have full control over this VPC. Anything that happens within this VPC, if there's any security breach, it is your fault, right? So you need you because you totally have full control over all these resources. You see the VPC, you see the subnets, you see the route tables, you see the network connections, right? You see there's an RDS internet gateway. Why RDS internet gateway? It is because there is a public subnet. When you have a public subnet, there is an internet gateway that is created automatically. Okay, yeah. So VPC S3. I mean, this is not important for now, but we could have had that. So here, guys. So we are done with with the networking. So let's move. So now we need to make sure that, I mean, there is a route table. Like there's a route that routes traffic from our VPC, that's the normal VPC, that's CIDR block 10.0.0.16, to all our subnets, right? That's the route table of our subnet. And there's also another public route that routes public traffic from the internet, that's the whole internet, to the through the internet gateway. Okay, so we can go check that. So let's go to route tables. First, let's check our public route table. Okay, let's check the public route table and make sure that there is a traffic, because the public route table there is routing traffic from the public through the internet gateway, right? So let's check that there is a route that route traffic from the internet passing through the to the internet gateway. So let's check that. Um, yeah, so you can actually see that there is a destination for all traffic that is from the internet. It passes through the internet gateway, and that's fine. Then for all traffic from our VPC, meaning that remember, this is our virtual private network. Any resource that is in our virtual private network can already access this subnet without any problem, because it is local, right? Without any problem. And yeah, that's fine, because they are all in the same virtual private network. It's okay. Yeah, that we have confirmed that. So we move ahead with security group, guys. So let's go for security group. Let's go and create security groups. So we're going to create our RDS security group. Okay, and we may create another security group for Bastion, right? So let's create security group. Let's call this RDS security group. Okay, let's describe it. Then the VPC, guys, you need to select the VPC that we created. Remember, they are our RDS VPC. Then for the rule, we do not need rule now. We're going to do that later on. So we can just leave that and create. Okay. Then we'll create another. We need to create another security group again. Maybe for our Bastion host, because we know that our RDS instance will be in a private subnet, and we need a Bastion host like a jump server to have access to it. So we call it, let's call this one RDS, let's say Bastion security group. Okay, then we can name it, we can describe it, then we select the VPC, our RDS VPC, and we create. Okay, Yep. So we are moving progressively. So what's the next thing? Let's go to subnet group, right? So let's go to RDS and Aurora. We create our subnet group for RDS instance. So if you move down here, you're going to see subnet groups, right? There's no subnet group, so you create a subnet group. Remember, a subnet group here is for high availability that I told you, right? You're going to bring in the subnets and the availability zones together and create a subnet group in such a way that if AZ1 is down, AZ2 takes up, right? So let's call it this RDS subnet group. Okay, so we can let's go describe it here. So we choose our VPC, that's our RDS VPC, remember? Okay, then the availability zones now. Remember, we need to choose our availability zones. We had two availability zones, not three. So we take EUS1A and EUS1B, right? And now we need to select the subnets. You see our subnets which we created. We're going to select the subnets. Okay. Remember, for RDS instance, this RDS instance is supposed to be in a private subnet. So we are selecting private subnet. So this one, RDS subnet public, no, we don't want that. RDS subnet private, yes, we want that for AZ1B. Now AZ1A, RDS subnet private, yes, we want that. RDS subnet public, no, and that's fine. You see that our RDS instance will be in a private subnet, okay? And we can, at this moment, we are very sure. Look at our CIDR, remember our CIDR block, our CIDR range, right? 1 and 2. This confirms that our RDS instance is totally in a private subnet, so we can create that. Okay, so with that now, we can now go to create our parameter group, custom parameter group, okay? Now, parameter group here, we need to first of all determine what RDS instance do you want to deploy. What is the RDS instance that we want to deploy? Let's say, okay, this time around we want to deploy a MySQL RDS instance, okay? Let's say you want to deploy MySQL RDS instance. So you need to be creating a custom parameter group for MySQL RDS instance, okay? So you go to create parameter group. Let's call this RDS MySQL, let's say MySQL parameter group, okay? Yeah, so parameter, okay, adjust that. So let's say RDS MySQL parameter group. Okay. Let's describe it. Now we need to choose the engine. What engine do we want? We said a MySQL. We are going for a MySQL RDS instance. Okay. We have been using a lot of Postgres, so let's go for MySQL. Next time we'll go for SQL Server, right? So let's go for MySQL. So you see MySQL community, select that. Okay, and now parameter group family. What version do you want? What version do you want to deploy RDS for your RDS? So you go for 8 version 8, right? So we are deploying MySQL version 8. And what parameter group is it? A cluster parameter group or a DB parameter group? This is a DB parameter group. Cluster parameter groups are for Aurora instances that have clusters. So you go to DB parameter group and you create that. Yeah, so you can see that your parameter group has been created, and now we can proceed with the deployment of our RDS instance. So we go to databases, we create database. Remember we said we created a parameter group for MySQL, so we are going for MySQL instance, and it was version 8, right? So remember, so we just go for the default version 8, no problem. And Now this is, we are going for a production and it's a multi-AZ. Okay, see, it's a production RDS instance and it's a multi-AZ. You see what's going to happen. And remember, multi-AZ, we say we're going to have a primary and secondary. As you can see it here clearly. So let's name the DB instance. So let's call it RDS. Call the RDS MySQL. Yes, MySQL. Now credentials. Let's call this SA. Can self-manage. So go for credentials. Yep. So DB instance, I had already explained DB instance. You can just choose I mean, you can choose any for. I mean, maybe go for a good instance, DBM7 large. Okay. So storage, you can go for IOPS or maybe GP2. Problem, I go for GP3. I don't need to love for now. It's testing purposes. I will enable auto scaling, right? I'll enable auto scaling because this is a production RDS instance. Then for connecting to EC2, I don't need it for now. Is this should it be publicly accessible? No. And security group, we need to select our security group which we created. Okay, first we need to select our VPC, right? Remember, we have our RDS VPC. Okay, then we select our database subnet group. This is which we created RDS subnet group, and VPC go for existing. You see, these are the subnet groups, security groups we created, RDS security group. You see, everything is in your control. Then additional configure, you can change the port if you don't mind. Then leave it for password authentication. Can leave enhanced monitoring, like if you want to allow enhanced monitoring, you can do that. But for production, I recommend you enable enhanced monitoring. Additional configuration. The first database name, let's call this testdb. Okay, first database called at testdb. For production database, guys, enable automated backup, very important. You enable encryption and so on, right? Minor version upgrade, you enable them. Enable delete, enable delete protection is very important. All of these items are going to help you to secure your RDS instance. Okay, so at this juncture, we can create our RDS instance. So our RDS instance is being created, and this is going to take a bit of time, right? So this is a well secured RDS instance that is located in an isolated, well controlled, fully controlled virtual network, right? That we can do whatever thing we want to do. Even if we want to scale to whatsoever category, we can scale without any problem. There is no default settings here. There are no default parameters. There are, like, everything is in our control. Okay. Hey guys, so we're going to wait a minute and for our RDS instance to get created. And before that, so remember, we need a Bastion host, right, to connect to our RDS instance. So we'll just rush away and go and create our Bastion host. So we'll go to EC2. So you search EC2. Let's create a Bastion host to authenticate. So you launch instance. Okay, so you name the instance. Let's call this instance RDS Bastion host. Okay, let's go for AWS, RDS Bastion. Let's go for Amazon Linux, the AMI. Okay, go for the free tier, no problem. The key pair, we do not have a key pair. We need to create a key pair, right? So you create a new key pair. So you create a new key pair and you'll be downloaded. Let's call it RDS Bastion key pair. Okay, let's call this RDS Bastion key pair and create a key pair. The key pair has been created and downloaded. then we can use it to create that, and that's fine. Advanced details, that's fine for me. And then we need to select the virtual network, guys. Remember, let's go for networking, very important. Should be in in our public subnet. So networking, uh, so we need to edit networking. So we don't need default. Let's put it okay in our RDS VPC, because if you use the default, we need to establish, we need to do a VPC pairing. So go choose this. Then we can leave it in our public subnet, right? Subnets. Remember, we had two public subnet. We can allow this in the public subnet since we need to authenticate from to this bastion host from the public, right? So so we have RDS subnet public 2 or RDS subnet public 1. Maybe we can go for RDS subnet public 1. Okay, we put it in there. Auto assign IP. Yes, so you should have a public IP, right? So we can connect to it. Then security group. We have, remember, we have our security group that we had already created for a bastion, right? Bastion security group that we already created. And advanced networking, we don't need that for now. Can leave that for now. And yeah, so you see, we have created our RDS instance, created a bastion host that we use to connect to it. And yeah, we are good to launch the EC2 instance. So while the EC2 instance is launching, we can go check our RDS to see the level at which it is now. So the instance is in modifying state. You can see CPU 26%. Okay, so can check logs, see some events, see how it's been created, DB data DB created, apply modifications, and so on and so forth, right? Yeah, so yeah. So let's wait for our RDS instance to be available as well as the Bastion host. Then we can now do some authentication. So then I will be showing you how you can authenticate to this RDS instance using your Bastion host from your local PC. I had already shown that in my previous video, guys. You can still watch that from your local PC, and I'll also show you how you can authenticate to this RDS instance using like we're going to use the MySQL workbench, and we're going to use the command line interface. Okay, so let's wait for these resources to be available. Yeah, guys, so our EC2 instance is ready and available. So if you click on that, you're going to see that if you can rush, let's rush to the IP. You see the private IP is that remember 10.0.3, right? It respects the CIDR range of our public CIDR block that we identified. Okay, so we can authenticate. We're going to use this EC2 instance to authenticate to our RDS instance, MySQL RDS instance as a bastion host. Okay, and if you see, let's look at the networking. It's in the public network. Look at our VPC, RDS VPC, right? And look at our subnet, right? So yeah, as we requested. So let's look at our RDS instance. RDS instance is also available, right? So it's available for us to authenticate into it. Okay, so the very first authentication approach, we're going to, let's say, want to authenticate from this bastion host using the AWS management console without using our personal PC, or like without using our work PC or our personal PC, right? Like we just want to authenticate to this RDS instance using that bastion host using through the AWS management console, right? So you go to the VP, you go to the EC2 instance, and you click on connect. Okay, so this is we can use, you can use a EC2 instance connect, right, to connect. So you click on connect. Yeah, so if you look at my screen, you can already see that there's a first error, and like this error, first we can already identify that we've not, there's some security group that have not been set, right? We have not yet allowed SSH traffic, right, at port 22 in this RDS instance. So we need to check that, and also make sure that there's also SSH traffic from that IP range, right? So we need to go check that. So if you see the security group, look at our security, the Bastion host security group. If you look at it critically, there's no inbound traffic. There's no traffic, right? We didn't allow any traffic. Okay, so that is the reason why we had that. So we need to add an inbound rule. So we add inbound rule, right? We need SSH, the secure shell, port 22. So this the source will be instance connect, like EC2 instance connect. Okay, so search EC2 instance connect. So let's go. We can go with IPv6. Okay. I think we can I'll just enable IPv6 and IPv4. Okay. So go with SSH again. Instance connect. This is IPv4. Sorry. Let's see. Yeah. Yeah. So this is for, let's say, allow instance connect. Instance connect. Same thing. Allow instance connect. Then I save the rules. Okay, so we can go back to our EC2 instance to connect. So we can cancel these. I'll try again, connect. Okay, successfully, you see we can authenticate to our EC2 instance, right? So guys, you saw what I actually did. Yeah, I actually allow SSH, like allowed SSH traffic from port 22 using the EC2 instance connect prefix, right? Because the EC2 instance connect is another service. So at this juncture, we can authenticate to our RDS instance using this EC2 instance, and we are still in the AWS management console. We are not in our local PC. We are not in our work PC. So that is another thing. So we are going to use first, we are going to use the MySQL CMD, right? Obviously, let's check if the MySQL CMD is there. So I'll search, so I'll go with MySQL. Let's say MySQL version. Check if it's available. So you see, it's not yet found because it's not yet installed. So let's search DNF to see if the MySQL CMD is there, so we can install it. So I will say DNF search MariaDB, right? Remember, guys, MariaDB, like and MySQL, they're the same, okay? So I'll search MariaDB. Okay, so you can see that, let's see. So we have MariaDB. See, this is the native client, okay? This is a native client library, this. So we can install this and authenticate, right? Using it, using this. So we can copy this, okay? And we install. Copy this again. So you go down and go with sudo, say sudo dnf install. Then we paste that client library. So paste the client library. Okay, so I'll confirm that installation. Yes. So you see the installation like it's been installed, right? So we now just check again MySQL and check if it's now available, MySQL version. Sorry, it's not yet found. Let me just check again. Yeah, so seems I installed a wrong client utility. So I'll go for the non-essential. Let me check that. This, okay. This the client utility, okay. Essential server utility for MySQL MariaDB. So I'll install that. So I'll go again for DNF install, and I paste. Okay, super user, so I'll go sudo dnf install, then I paste that. What's going on? I missed something. So sudo correct that. Yep, install. Yep. So I'll accept that. That's fine. Yeah. So installation is ongoing. So the installation is done, and I will check again if if the MySQL client has been installed. So I'll check MySQL at that version. Yeah, so you can see there is a version, so we can authenticate to our RDS instance using the MySQL command line interface. Okay, so at this juncture, we go to our RDS instance and copy the essentials. So we need the endpoint, remember. So we need the endpoint. The port is 3306, and we need security group adjustment, right? So we need security group adjustment. And so very first thing, let's go allow that EC2 instance to have access to the RDS instance security group. So let's go to security group. Mm, Security group. Let's adjust the security group, right? So that instance can connect. So there's no inbound rule. So there's no way we could authenticate. So we edit inbound rule, add a rule. MySQL, okay, 3306, and we want to authenticate from that our EC2 instance, right? So we'll use our security group. Remember, is we just use our EC2 security group. So we can just security group. You see, this is our RDS Bastion security group, okay? So we call this Bastion to RDS. So we can save that. Yeah. So we can go back to our EC2 instance and authenticate, right? So we can just copy the RDS endpoint. So I'll copy the endpoint, okay, for authentication. So back to our Bastion host, right? So I'll paste this. So if you look very well, the very first thing is we use the MySQL utility, right? So we are using the MySQL. Let me push this down. So we are using the MySQL utility. Um, so MySQL, then the host name, right? The host name is the RDS endpoint. Then the port is 3306, right? Then the user is SA, my own user, and the P for the password. So I hit enter, and they'll ask me for the password. So okay, so finally authenticated to this MySQL RDS instance using our Bastion host. Okay, so this is the most secure way for you to authenticate your RDS instance. Okay, with this you have not like you've not authenticated to this RDS instance from your local PC, you are still using resources around your AWS environment without any issue. Okay, so now I'm going to show you if you require to use maybe some people like the graphic user interface, some people like the command line. If you want to use the graphic user interface, maybe the MySQL Workbench from your local PC, or you want to use the command line interface from your local PC, remember guys, it therefore means that you need to do two authentication. First, you authenticate to your Bastion host, and secondly, you now authenticate to your RDS instance. So let me show you that in my next screen. So as you can see on my screen, we have our MySQL Workbench available. So what we are going to do, guys, we're going to use our key pair. I'm now in my local PC. We're going to use our key pair, right? We're going to get our key pair. We authenticate to our Bastion host. Then from the Bastion host, now we now authenticate to our RDS instance. So what you do now, you go to databases. So you go to databases and you connect to database. Now you are not using, we will not use just the normal TCP. So we're going to use select we go TCP over SSH. Okay, you see what I selected? We are not going to use the normal standard TCP, but we select TCP, this standard TCP IP over SSH. Okay, so then let's name this connection so now the host name, the SSH host name, we go get uh, our EC2 Bastion DNS public DNS hostname. Okay, so we go back to our EC2, right? And we go to details. So we get the host name, public DNS. It's a public DNS, so you copy the public DNS and you go back. So back to our workbench. So we go to connect to database. Yeah, so at this juncture, we paste the DNS, the public DNS of our EC2, right? Oh, sorry, need to be standard TCP over SSH. So we paste the public DNS of our EC2. The username by default is EC2 hyphen user. Then now the password, we are going to use the key. So we're going to select the SSH key. So go to my download, RDS Bastion host key. Actually selected it. Okay, so see, I've imported the Bastion host key. Okay, when you select this, it's going to direct you to your local PC. You bring in the the key pair, right? So so the next thing is the MySQL host name, which is the endpoint of your RDS instance. So you paste that. The port is that, and the username, my own is SA, and the password, right? So set the password. Okay. So save it, and what I will do, go to okay. Before we even go to okay, guys, remember we need to go set security groups, right? We need to allow our local IP to have access to the Bastion host. Okay, that's important. If not, we'll not be able to authenticate. So let's go check that. Yes, so we go to the EC2 instance. We go to security. We're looking for the security group. So here's the security group. You see that there's no inbound traffic allowing like there's no inbound rule allowing traffic from my local PC IP to the Bastion host. Okay, so I need to allow that. All right. So I'll go to security group. Then I'll edit inbound rule. Okay. For inbound rule, I'll allow SSH again. I'll allow SSH. SSH custom, so call this custom, but I will select my IP. Okay, so I'm going to select my IP, so should like I do not have a static IP, right? So I'll select my IP. Yeah, so I select my IP and I can name this um my my PC my PC to Bastion, and I save the rule. Okay, so the rule has been saved completely, and I can now access to I can now authenticate properly to my EC2 instance without any problem, right? Okay, so we have to select again. So we bring in the EC2 host name, the user EC2 hyphen user. Then we bring the key pair, right? So you select this three ellipses button, and you bring in the key pair. So key pair uploaded. Then my SQL host name is the RDS endpoint. So I bring the endpoint, the port is that, and the user SA as I did. Then the password, I'll bring in the password. So I'll bring in the password. Okay. So I selected store in vote and brought in the password. Then I can now go for OK.